welcome. This is Math Hands TRIG, our first lecture. So today I want to welcome all of you and first and foremost tell you that it's an honor and a pleasure to share these timeless ideas with you. It's exactly what we want to do, and besides that, I hope you'll like it, and I hope to do no harm. So here we go. We'll start off with what I call the great promise of trigonometry. This idea that you could just look at things, glance at them, and just by glancing at them, you could, on a good day, figure out how big they are. That right there, that's a very nice idea. It could make you the life of the party. In fact, that's the idea that changed a lot of things in real life. It doesn't just apply to trees. I mean, trees, you could conceivably just climb up there and do it yourself. You don't really need fancy trig ideas for that. It applies for houses, but you really start to see the power of that idea when you start to apply it to things that are far, far, far away, like a mountain. It's not as practical to go up there and measure the mountain, say by hand or by old methods. Trig provides a very elegant solution. It says, hey, no need to worry, you just glance at it from very, very far away and you can tell how big the mountain is. You can tell how many inches of snow there is on the top. You can tell how many squirrels live there, etc., etc. It really is powerful when you start to apply it to things far away. An airplane that could be miles above you, you just glance at it, and by taking some angle measurements and whatnot, doing some nice trig stuff, you'll know exactly how big that or how far away the airplane is, or how high it's flying as well. And that's when you start to see the power of this idea, that you could apply it to the moon, the planets, just about anything you want. You could apply it to your mother-in-law. You could just glance at her, size her up just the minute you see her. That in it by itself would be worth the Math Hands subscription, in my opinion. Just by a little quick glance, and you can size her up just like that. All right, that's the great promise of trigonometry. Of course, there's a lot more to it. So we have an easy lecture today. I'll just give you a sort of overview. There's no homework today, but I think we want to start off kind of easy and easy into these timeless ideas. Let me explain the fundamental principle of triangles. I just made this stuff up. I don't think, if you Google that, I don't think you'll find anything. But I think it really should be called the fundamental principle of triangles. And it goes like this. This is what, this is the basis for you being able to look at things from far away and being able to measure them. You got to get a good grip of this principle. The principle goes like this. If you're going to measure the moon or a house or your mother-in-law from far away, what you've got to be able to tell us how big is it by just looking at the angle over here. Big angles would make big sides, small angles would make small sides. So these triangles are arranged where an angle corresponds to a side directly across from it. And the fundamental principle can be stated as follows. If this right here is a small side, well, small compared to the other two sides, well, that angle right there would be a small angle. That is, compared to the other angles. Say if this angle measures 10 degrees, maybe this one measures, I don't know, 5 inches or something like that. The other ones would measure maybe not 10 degrees, but maybe 70 or 80 degrees. And across from them, you would find something that measures a lot more than this one. So, small little angles make small sides across from them. That right there, that's the fundamental principle of triangles. Or said differently, small little sides will make small little angles across from them. That's how you can tell how big things are, by measuring the angles. Well, not really, but that's part of the story. That's a fundamental piece of the puzzle. Let me elaborate on that. Now, compare that with the previous one. See, this one, small little angle makes small side. Small side. If this was a little bigger angle, would make a little bigger side. Okay? Slightly bigger side would result from a slightly bigger angle, all else being the same. And of course you could take that to a different degree. You know, a smaller, even larger angle would make an even larger side. This concept is so easy I could do it with my left hand. Look at this. An even bigger angle would make an even bigger side across from it. See that? You can change it with magic, look. I told you. That's why they pay me insane amounts of money. Anyways, take a look at that. Let's see if we can do it in sort of slow motion. As you see this angle grow, you see the side opposite grow. That makes perfect sense because, well, it's common sense. The bigger the angle, the bigger the sides across from it. So this thing could be like a huge tower. Maybe this one is a small building. Maybe this one's a car. Maybe this one's like an ant. That's how you measure things. That's the principle behind the stuff we're doing. Of course, that doesn't tell you the whole story. It's just a little piece of the puzzle, but a very, very important one. The rest of the puzzle can be summarized as the idea of quantifying this principle, more or less. By quantifying means don't just be happy saying that small angles make small sides and bigger angles will make bigger sides, but actually put a number on it. If this is so many degrees, exactly how many inches will the other one be? Or if this is so many degrees, exactly how many miles will this be? That starts to get a little bit deeper into the principle and starts to demand more. And it starts to demand a deeper, a better, a more complete explanation. Not better. This is as best as it gets, but it's not complete. So let me add the other pieces of the puzzle, if we can. So figuring out how each of these angles affects the opposite side can be summarized into this idea of solving the triangle. Let's elaborate on that. We look at each triangle as 6 pieces or pairs. You know, this is a pair. That's this side comes together with this angle. Each will affect the other. If this angle is big, so will the opposite side. If this angle is small, so will the opposite side. So they come in pairs. Usually, it's customary. It's been customary for over 1,000 years to name them accordingly. If you call this little a, for example, you would call this big A, or vice versa. Sometimes people use Greek letters. If this is alpha and this is A, it's quite common to use Greek letters for the angles, Roman letters for the sides, or smaller case and uppercase, etc. But within this same triangle, you got other pairs that are interesting, or will be of special interest. You could look at this corner over here, and opposite of it is this side. Again, you see this notion that making the angle big makes the opposite side big. So these two come in a pair. If the other ones was, that one was called A and little and big A, this one would have been called B and big B. Or sometimes it's also common to call them beta and B, something like this. Greek letters as opposed to Roman. Greek is usually used for angles. It doesn't have to be, it's just tradition. And of course there's the other pair here. This angle corresponds to the side directly across from it. So in this way you can pair them up. These two are intimately related to each other, so are these ones and so are those. But really they're all related to each other because they belong to the same triangle. This idea of solving the triangle can be reinterpreted as finding out the quantity, how big each of the 6 pieces is. What I mean when I say find out what they are, I mean the measurement. These would be linear measurements, these ones would be angular measurements, how big the angles are. That's what it means to solve the triangle. To solve the triangle means figure out all 6 pieces. And so we have this very powerful way of looking at a triangle. We don't look at a triangle just a triangle. Instead, what we want to do is say, you know what, that triangle is no longer just a triangle. What it is a bunch of pieces. It's that side, it's that side, it's that side, and it's a few corners. It's this corner, which we call an angle. It's this corner, which we call an angle, and it's that corner, which we call an angle. So in that way, instead of looking at it at a triangle as just a triangle, we look at it as 6 pieces, 3 angles that correspond to 3 sides. 6 pieces. This is a powerful way of looking at the triangle. And I can't tell you why it's so powerful because you got to wait for the course, but for right now you got to take my word for it. This is a powerful way of looking at the triangle. No longer just think about it as a triangle. Think about it as 6 pieces, 3 sides and 3 angles. Now, what we mean when we say solve the triangle is we mean the following. Solve the triangle means the following. Suppose you could, by some method figure out 3 of these. Suppose somehow you could get lucky and measure that angle, and measure that side and measure that angle. So you've got these 3 done. But suppose you don't know these ones. You don't know what the missing items. When we say solve the triangle, it means out of the 3 that you know by some other means, solve the rest of them so you can have all 6 pieces. If you know this is 10 feet and that's 20 degrees and that's 50 degrees, can you figure out how long this is? If you can figure out, oh, this is 17 feet or 20 feet and this is 152 degrees, then you've solved it. That's what we mean when we say solve the triangle. And it could be any sort of combination. Maybe somebody gives you these 3 items, those 3, and they ask you to figure out the ones that are under the hands. Or maybe they just give you the sides and they don't give you any of the angles and say figure out the missing information, figure out exactly the 3 angles. Or maybe they give you 2 sides and the 2 angles on one side. Any sort of combination is a feasible challenge for you to solve. It can't always be solved. Some propositions are just unsolvable because there's no real triangle that fits that criteria. Other propositions have more than one solution, but every once in a while you get lucky and you have exactly one solution. Even from just 3 items that are known, you can figure out completely what that piece has to be, what this piece has to be, and what that other angle has to be. And when that happens, you can say to yourself, winner, winner, chicken dinner. You've solved the triangle. The actual technique of solving the triangle, that's exactly what we're here for. That's the trig part. That still doesn't really explain how that's going to help you become the life of the party. Let me remind you. One of the principal objectives here is to be able to look at something really, really, really far away and say how far away it is, or say how big it is in diameter. Crazy things like that, unthinkable. And one of the underlying principles is this idea that little angles make like little sides. The great promise of trigonometry is that what happened to the great promise of trigonometry? That you will be able to just look at something. This is the great promise of trigonometry. If 3 items are known, however they may be known, maybe an insect measured them for you and gave them to you, or maybe they're easy to measure. If 3 items are known, the great promise of trigonometry is that on a good day, it will deliver the other three items for you, and that's really, really, really good. Of course, the other part of the puzzle is explain why is that good. How is this 3 items known, 3 of them are missing, connected to this? Figuring out how big the tree is. Okay. So that's the last part of the lecture today. Let me explain that part. You want to measure how big this tree is. The key idea is to make out of the length that you want, that side, make that side be part of a triangle. So we could easily do that. We could take this this person right here. Let's ungroup these so I can move him around. And let's lay yourself down here on the floor. Just relax. And the reason I want to do that is so that it's at the same level as a tree, because this is going to be part of the triangle. It will look more or less like this. And what we do is we say, okay, this side right here, I could measure this side. Even an insect could measure this one. This side is easy to measure, and the reason it's so easy to measure is because it's on the ground. You know, I don't have to climb up the tree. It's practically there. You just go from the trunk of the tree to some distance over here, and you just lay down. That side is easy to measure, so check on that one. Moreover, we can assume that this tree is upright, or even if we can't, let's just assume that it's upright. That would give us this angle right here. This angle is 90 degrees. Okay? And let's just say for hypothetical purposes that this side is 120 feet. Okay? Whatever. Moreover, we look at the top of the tree from where we're laying down. We look, just glance at it to the top of the tree and measure this angle. Suppose this angle is, I don't know, 21 degrees. That right there, that's the key. That's where the other part comes in. A small angle would have made a small tree. A bigger angle would have made a big tree. And what we want to know is how big of a tree does a 21 degree angle make? These angles are easier to measure because they're on the floor. Now, what we want to do is, what does that have to do with 3 items are given, 3 of them you find, and the idea that you could measure things from far away? Well, we've got it right here. We've got exactly what the last part of the puzzle here. Because what we want to do is complete a triangle out of this. It'll have that part is missing, this part is missing, and this angle is missing. So 3 items are missing. But suppose you go on and you solve them, and you say, okay, check, I got that, check, I got that, check, I got that. I'm not telling you how to solve them. That's why we got to do the trig course. But the great promise of trigonometry says, hey, if you can get 3 items, if 3 items are known by whatever means, there's hope. On a good day, we can deliver the other 3 items. That's the great promise of trigonometry. In this case, what that means is that, you know, an insect can measure these items down here on the floor. We'll use the great power of trigonometry to figure out the rest of the triangle, and voila, there it is. By figuring out, you'll figure out the rest of the triangle. You figure out exactly how many degrees it is. You'll figure out exactly how many feet this is, and you'll figure out exactly how many feet this is, and there it is. Winner, winner, chicken dinner. You will know exactly how big the tree is from just looking at it from far away. See that? See why they pay me? Insane amounts of money? But wait, there's more. You may say, oh, that was too silly of an example. Anybody could do that. You know, what if the tree was up on the you know, up in the sky, flying around? Huh? Try that. Or, for example, you know, I got a little crazy with my intro here, thinking that we could figure out things about a tree or about a bird flying way up in the sky. How are we going to measure that? No worries. I got that covered. And there's plenty more where that came from. Here we go. So the first goal would be, hey, I measure the angle of elevation from where I'm at to the horizon, and I measure this angle. Say it's whatever, 27 degrees, right? That's one item. Check. And then I'll move. Let's do a copy and paste. Haha. And let's move, say, I don't know, how much do you want to move? Let's just say we move, I'm going to say 52 feet. Oh yeah, you have to move super, super fast and pretend that the bird is frozen, not moving, okay? Whatever. But then, from where you're at, now you measure the angle again and say this angle is, say, 89 degrees, or 88 degrees. That was a good year. And now, look what you got. Look what you've got here. You've got 2 angles and a side. How many pieces of the puzzle do you have? 2 angles and a side. What is the great promise of trigonometry? The great promise of trigonometry is that if you know 3 of the items, trig promises on a good day, bam, it will deliver the other 3 items for you. I told you. Didn't I tell you? That's why they pay me. So, what does that mean for our scenario here? So you've got this bird up here flying, and what you've done here is you know, let's see, that's part of the triangle, that's part of the imaginary triangle, and of course this angle right here is part of the imaginary triangle. But trig promises, if you know 3 of the items, on a good day it will deliver the other 3 for you. So you got 1, 2, 3 of the items. So therefore trig will deliver that side, it will deliver that, it will deliver the angle. Bam, guess what you just found out? You will have found your original distance, how far you were from here all the way to the top. All the way, exactly how far you were from the bird. And the bird is really, really, really far away. Isn't that nice? That's elegant. That would make you the life of the party. And there's plenty more where that came from. But I don't want to tell you too much today. Gotta always leave them wanting more. That's what they say, right? So, if I had to tell you in 5 minutes the essence of trigonometry, it's exactly this. Let me go back and put all the pieces of the puzzle together. We want to be measuring things from far away. Houses, mountains, anything, okay? Your mother-in-law, fine. The underlying principle is this idea that if you change the angle, you change the side. No problem there. How do you quantify it? Well, you got to solve the triangle. What does it mean to solve the triangle? You look at it as 6 pieces, pairs of angles and pairs of sides. Sorry, pairs of angle and side, opposite of each other. But to solve means you look at it as 6 different pieces. And if you know 3 of them, the great promise of trigonometry is that if you know 3 of them, trig will deliver the other 3 for you. And how is that useful? Well, let me count the ways. Any sort of thing that you want to measure, you can make a triangle out of it. All you got to do is make the triangle in a clever way. And usually you can keep measurements close to you that you can actually figure out. Don't use the measurements that are far away that you can't figure out. Use the ones that are close to you. And usually you can get 3 out of the 6 without much effort. Even thinking like an insect, you can always get 3 out of the 6. Oh, but then you use trig, the power of trig, to figure out the other 3. And there it is. Delivered. They call me the mailman because I deliver. Alright, so that right there in a nutshell, that's the course. Well, it's not really the course, it's 1/3 of the course. This great promise of trigonometry, this mission of being able to quantify this ratio of sides and angles and solving triangles, it's 1/3 of the course. The answer to that came from these very things called functions. You may have heard of them: sine, cosine, tangent. The study of these functions would be another 1/3 of the course. We study their graphs, properties, equations, formulas involving them. A huge part of the course, even after we've already solved the original problem. We'll spend a lot of time with the functions. The last thing is this very elegant miscellaneous set of topics like vectors and polar coordinates and Euler's identity. Huge, elegant. It's not what I would call mainstream trigonometry, but it's traditionally taught in a trigonometry class. These 2 items is what I would usually call trigonometry. The great promise of trigonometry, being able to solve triangles, and the study of the functions. This is sort of miscellaneous, but it's for some reason traditionally always taught in here, so we'll take a look. We're not afraid. Okay, in a nutshell, that's our course, and that's our day for today. The very last thing today I want to do is, just because it's the first day, I want to say just 1 or 2 words about the course. The course is designed with the 3-punch combination principle, meaning that there's 3 punches to the learning process here. 3 crucial tools. The videos is just part of it. It's a very passive activity. You just watch the videos. And they're very good, but they don't get the complete job done. It rarely does it mean that just by watching the videos magically you learned everything. It really involves some work on your part. It's like riding a bike. You can't really learn to ride a bike by watching others. Well, most of us can't anyways. The homework is crucial, and I wrote it this way on purpose because they actually take you to a step higher and higher. Sometimes the homework will ask for more than what the videos provided. That's by design. I really think that you're capable of so much more than just repeating whatever I said on the videos. These give you principles. Notes and the homework take it sometimes a step or a couple steps beyond that, giving you an opportunity to grow. And of course the self-quizzes are even better than the homework. They take you even a step further than the homework. They are pedagogical masterpieces. They're designed to ask and answer things at the same time. You gotta select multiple choices, but more than one could be right, so it makes it very, very interesting. It's forcing you to look at a problem in 10 different ways sometimes, which is really, really the essence of mathematics. The goal here is not really so much to get the answer. If you want the answer, all you do is Google it. Google will tell you all the answers. The goal here is to think and to become creative and more confident in your own thinking process. It's a very unmodest goals, but it's what we want here. We don't want to take the easy way. We want to get the most out of this course. If you're going to be here watching these videos, you may as well get the most out of it. Okay? That's what we want. Let me see if I can pull out one of these lessons from Math Hands. Most of the Math Hands lessons will look something like this, with some variations of the icons here. All these icons are things that are part of the lesson. Usually you'll have videos. Sometimes there'll be QuickTime files that you can download. Sometimes they're Flash. Then you have exercises and notes. Click on this, you get a PDF file. That's the homework. That's step 2, first step, second step, and then the third step, the quizzes. Okay. Almost all of them will have these icons here. Sometimes they don't because they're not appropriate. For example, this lesson is just for watching, so you wouldn't have homework on it. You just have the video. And of course, you could check the solutions. This is a check for the exercises. And ask questions. You're always welcome to participate. I love questions. You can post them, and also you can read what others have asked. So again, I welcome all of you. This is a great privilege and honor for me. I love doing this, and I hope that I'll be able to share some of these timeless ideas with you, and we'll all be better for it. Okay, sound good? I say we should call that a wrap. Okay, see you guys. Peace. Get this party started.